Much like with exponential equations, we also have a property of equality for logarithmic equations. So if you've got these log equations here, like this, log base b of x equals log base b of y, and b, x, and y are all positive, and b does not equal 1 because the base of the logarithm cannot equal 1, then that implies that this x here, the argument of this logarithm and the argument of that logarithm, have to be equal to each other. So for a quick little example there, if we had log base 2 of x equals log base 2 of 8, then x would have to equal 8. Alrighty, so we're going to take that to some problems that are a little bit more interesting there. Our first one here says log base 2 of 2x plus 3 is equal to log base 2 of 15. We do have the same base on each of the logarithms over here, so that means the arguments of those logarithms must be equal to each other. So 2x plus 3 equals 15. Now I have a basic Algebra 1 linear equation that I could solve. So I'm going to subtract 3 from both sides and then divide by 2. Okay, now it is possible that we have extraneous solutions on these, so we do actually have to check these. What you're checking for is you're checking to see if the value of x that you got when you put it back in place of x in the arguments of the logarithms, if it makes this argument something that is not positive, then it's not really a solution. And that would have to be true for all of the arguments, but on this particular equation, there's no x in this other one. So if I took 6 and I put it in place of x here, that would be 2 times 6 plus 3, which would be 15. And that is a positive number, so that means 6 is a good answer. Okay, we'll try one more like that. We've got log base 5 of 4x minus 7 equals log base 5 of x plus 5. We do have the same base on the two logarithms here, so that means that the arguments must be equal to each other. So I can start just by saying 4x minus 7 is equal to x plus 5. And then I just have a simple Algebra 1 equation here, linear equation. So I'm going to subtract x from both sides, and I'm going to add 7 to both sides. And then I can divide by 3 to finish solving there. Now, once again, before I declare that this is the answer, I do have to make sure that this value of x does not make either of my arguments of my logarithms something that's not positive. So if I were to put 4 in place of x over here, I would have 4 times 4 minus 7, so 16 minus 7, that's still positive. And on the right, 4 plus 5 is also a positive number. So x equals 4 is a good answer. Okay, now you have a couple on the Google form to answer.